Assalamualaikum and hello everyone. Welcome to the last video of Chatellier's principle. Where in this video, we will look at for the summary and the examples for Chatellier's principle. So for the summary here, it is not available on your notes, so please write it down. Okay, so we have looked for several factors regarding our Chatellier's principle. First thing first, what we're going to look at is actually in terms of concentration. Okay, so for the concentration ni, again, in terms yang K itself, we only concerning about our gas dengan aqueous sahaja for concentration. Okay, and then for the concentration, this case is actually, kita tengok dekat sini, for this is our left hand side is the reactant side, our right hand side is the product kan. Okay, for the case of concentration, we will not look at the stoichiometry. So even though kat sini here is 3 mole, here it's 7 mole. So we're going to assume before we're going to increase ataupun decrease the concentration of reactant or product. Okay, here kita akan assume sahaja it is balance lah. As in our seesaw ni dia adalah balance. Regardless here is kat sini kita tengok 3, here it's 7. Okay, so in terms of concentration ni, there are two ways of seeing it. First is actually in terms of yang seesaw ni lah. Okay, so first one, kita tengok sini. When we increase the concentration of reactant, so assume the red one is the reactant and the green one is our product. So what will happen? This block will be bigger. So it will be tilted to one side kan. So when it is tilted to one side, what we're going to do is actually we're going to make it balance. So how to make it balance? So we're going to shift it to the right. Barulah kita dapat balik macam ni. Shifting to the right. So that's why lah kita akan bagi tahu the equilibrium will shift to the right. So what does it mean by shifting to the right ni? Shifting to the right ni, it means that our reactant ni akan jadi produk. Kita punya ni, our arrow here will be to the right. Ataupun kita panggil dia forward reaction lah. From the reactant to our product. Okay. That is one way of seeing it. Another way of seeing it is actually, so the reaction is balanced. When we increase the concentration of the reactant, the system will counter back. Kan kita increase concentration of reactant kan? It will counter back by decreasing the concentration of reactant. So when it decrease the concentration of reactant, macam mana kita nak kurangkan concentration kat sini? We have to change it into product lah. So when the reactant change to product, it's actually shifting to our right. So that's why lah, the equilibrium will shift to the right. Okay, so kita tengok dekat sini pula, kalau kita buat yang in terms of increasing product lah. So for example here, so first the system is balanced, but right now when we increase the product, here will be a bigger block. So bila jadi bigger block, it will become like this. So when it is not balanced, will it shift to the right ke left? It will shift to the left to make it balance back. So kita bagi tahu lah, equilibrium will shift to the left. Or another way of saying it, the reaction is in equilibrium, but then bila kita increase the product, the system will counter back the disturbance by decreasing the product itself. So bila dia nak decrease the product tu macam mana? Dia akan decrease kan dengan tukarkan produk kita ni jadi reactant. So from product to reactant, product to reactant ni, it's actually shifting to the left lah. So dia bergerak ke kiri kan. So that's why lah it shifting to the left. Left ni the same goes as our reverse reaction, where the product will change to our reactant. So that's there are two ways of seeing concentration ni. It's either nak tengok in terms of seesaw ataupun fikir kita nak counter back the changes. Okay, so that is for concentration. Next, we look at for the temperature. Okay, so for the temperature, it is important for you to know whether it's endothermic or exothermic. Okay, why? Endothermic, where delta H is positive. Sometimes question tak bagi tahu endo, dia bagi tahu delta H is positive sahaja. So these two bits is important lah. So delta H is positive is endo where heat is absorbed. So when heat is absorbed for the reaction itself, senang kamu buat heat tu is actually on our reactant side. Kalau exothermic ataupun delta H is negative, it is when heat is released to the surrounding. So when it is released, so that's why heat ni kita akan buat in terms of product. Okay, so kita tengok kat sini, I'm gonna explain in terms of endo sahajalah. Again, when temperature increase, kita assume sekarang ni dah balance dah. So when temperature increase, this system will counter back. Dia akan counter sebab dia dah kacau tambah temperature kan. Dia kacau balik. Dia akan counter back by decreasing the temperature. So, when it try to decrease the temperature, dia mestilah nak pergi tempat sejuk kan. Tempat sejuk tu, temperature decrease tu is where kita tengok tak ada heat pun kat tempat dia. So, dalam kes ni, tak ada heat tu is in our right hand side lah, tempat produk kita. So, that's why lah, reaction shift to the right. But then, kita assume the reaction is in equilibrium, tapi kita decrease the temperature. So, what will happen is that, dia akan counter back by increase balik temperature dia. Temperature, how to increase the temperature, kita tengoklah heat tu di mana. So, here heat is actually on our reactant side or our left hand side kita lah. Sebab itulah dia shift to the left. The system ni pun macam kita lah juga Kalau contohnya hari tu hari yang panas, kita mesti nak bubble tea ke, kita nak kita nak ice blended. Tapi kalau contohnya hari tu sejuk, satu malam tu hujan je, kita mesti nak makan Maggi kan, makan benda yang panas. Macam tu lah juga chemical system ni. Kalau macam dia suka just nice macam tu lah. Kalau dia increase temperature, dia try to decrease balik. Kalau contohnya kita decreasekan temperature, dia try to increase balik lah. So, itu kita tengok in terms of endo. Exo tu is actually on, is vice versa lah. And then, kat sini ada juga mention pasal K. So K increase. K tu is actually about our product over reactant lah kan. Ni product over reactant. So kalau K increase ni, it means that product kita is bigger than our reactant. So sebab tu lah, the shift to the right ni, K dah akan increase lah sebab product is form more. The same goes kat sini. Kalau temperature decrease for our exothermic reaction. Sebab we shift to the right, product yang form banyak. So that's why lah K increase. Kenapa dekat sini K decrease? Again, K is actually product over reactant. So dekat sini, bila shift to the left, so it means reactant yang banyak form, product yang sikit. So that's why lah K ni is a small value. But then again, this type of question, in terms of K ni, dia tak adalah selalu tanya. But it is also important for you to know lah. So that is for the terms of temperature. So the third one, we're going to look at in terms of pressure. For the pressure itself ni, it is only applicable for gas only. And then, for the pressure ni, it's important to consider the mole. Dekat sini kita akan tengok stoichiometry. Contohnya dekat sini kita tengok ni 3 mole. Here will be our 3 mole. Sini akan jadi kita punya 7 mole. So kita akan still lagi shift to the right or left. Tapi penting untuk kamu tahu which one ada higher moles ataupun fewer moles. Why? Because when the number of mole is low, the pressure will become low. So contohnya, when the number of mole is low, so the collision between the molecules itself ataupun the collision between molecules and the wall of container tu decrease lah. So that's why lah pressure dia pun decrease. Because pressure, we're talking about the collision between the molecules and the wall of the container itself. So when the number of mole increase, so contoh kat sini kita banyak lagi ada 6 So the pressure there will become higher lah sebab the probability of collision tu will become higher. So sebab itulah untuk pressure, important for you to look at in terms of mole lah. Higher number of mole ataupun lower number of mole. So contohnya, kita akan assume saja it is actually in equilibrium. Kalau kita increase the pressure ataupun decrease the volume, sebab this is actually based upon our Charles law lah. Volume is inversely proportional to pressure. The reaction is balanced, tapi what we're going to do is actually kita pergi increase the pressure. Increase the pressure ni kat sini. So what will happen, the system will counter back by first dia akan decrease the pressure lah. So decrease the pressure tu macam mana? Dia akan cari lower number of mole. So tengoklah, sometimes it will be on your, dalam case ni lower number of mole kita ni is actually on our left kan. Tapi ada juga equation yang lower number of mole tu di bahagian right kita. Tengoklah pada mana. So for pressure ni determine mana satu yang lower number of mole and lower pressure. When the pressure decrease ataupun volume increase, so what will happen is that the system will try to counter back by increase the pressure. Increase the pressure mestilah higher number of mole. Okay, so that in terms of pressure. Okay, the next we're going to look at in terms of inert gas. Inert gas ada two condition. Constant pressure ataupun constant volume. Okay, constant volume ni senang sahaja. There is no changes. Tapi kalau kita constant pressure, we're gonna act as if the partial pressure to decrease. Okay, kenapa? Ini mesti terangkan banyak lah previous video yang kita we have done the calculation. But then this summary kan, so we're gonna act as if kita decreasekan the pressure. So bila kita decrease the pressure, sama macam sebelum ni. Bila kita decrease the pressure, the system will counter back by trying to increase the pressure lah. So nak increase the pressure, dia pergilah, mestilah pergi pada higher number of mole. Okay, and last but not least, we're going to look at for the catalyst. Catalyst pun no changes, the same as inert gas at constant V. Okay, so that is actually the summary of Chatelier. So if you're a bit unsure, boleh tengok balik lah. Where the video tu memang Miss dah explain kan. Each of it, concentration, pressure, concentration, temperature. Video pressure tu ada includekan inert gas dengan catalyst. Okay, so that is the summary. So now let's look for our examples. The first example that we're going to look at is actually example number 1. Okay, predict the changes in equilibrium if. Okay, so dia bagi dekat sini. So what we would like to do first is actually, so kita tengok kat sini, delta H kita is positive 38.5. So positive ni is actually our endothermic reaction. So endothermic reaction is actually heat is absorbed. So heat is absorbed, heat is actually on our reactant side. Okay. Lepas tu apa lagi nak guna lagi concentration reactant tak nak. Okay, kita tengok in terms of pressure pula. So dekat sini, here is actually 1 mole. Sini adalah 2 mole. So bila 1 mole, number of mole dia low kan. So pressure dia pun become low. Tapi ni number of mole is higher. So pressure dia become higher. Okay, nanti senang kita nak tengok macam mana nak, once kita tulis sini, senanglah kita nak predict the changes. Okay, so the first one we're going to look at is the reaction mixture is heated. So reaction mixture is heated ni, the same goes as temperature increase. Okay, so when the temperature increase, the system will try to counter back by decrease the temperature. Decrease the temperature tu where there is no heat lah. Dalam case ni, our left hand side reactor ni ada heat. So what will happen is that the equilibrium will shift to our right. Sebab kat sini tak ada heat kan? Sebab dia nak counter back the changes. So the equilibrium will shift to the right. Okay. So next what we're going to look at is NF2 gas is removed. So assume sekarang ni is actually balance macam ni. Okay, so the balance macam ni kan. So bila NF2 is removed, what will happen? Ni makin jadi kecil lah ataupun tak ada. So bila tak ada, dia akan jadi macam ni. Macam ni ini saya buat kecil lah. Okay, so what will happen? It will shift to the right. Ataupun, sebab kita dah tahu, when NF2 is removed, so maknanya NF2 ni berkurang. So, what will happen is that the system will try to counter back by increase the NF2. So, bila dia increase NF2, dia akan shift to our right. Sebab dia nak form lagi banyak NF2 lah. Sebab dah is removed kan. Equilibrium will shift to the right. Okay, so next one. The pressure decrease. So what will happen is that the system will counter back by increase balik dia pressure. So bila pressure increase, ada nak pergi mana? Left hand side kita ni ke ataupun right hand side? So nak counter back dengan increase the pressure kan? So increase the pressure, dia nak on our right hand side. Okay, the last one, inert gas is added. Ini kita nak constant ni lah, constant pressure. Okay, so when inert gas is added, ada two cases. It's a constant pressure ataupun constant volume. So, kalau constant pressure, effect dia as if pressure decrease. We make some changes by decreasing the pressure. The system will counter back by increase the pressure. So, bila increase the pressure, equilibrium will shift to the right. Sebab, the higher the number of mole, lagi higher lah pressure kita. Okay, so that's for question number 1. Okay, question number 2, I believe you could try yourself. Remember, to answer the question, dia memang suka gabungkan. Bagi satu equation ni, so gabungkan lah. Okay, so what we're going to do is actually tengok in terms of kalau temperature, depends on delta H kita. And then, for the pressure ni, remember it is only pressure must only be gas lah. Okay. And then from here barulah kita tahu mana higher pressure ataupun lower pressure. Okay, so right now we're going to look at for the question number 3. Okay, so dekat sini, what would happen to the equilibrium position if some of the CO2 were removed? Okay, so CO2 were removed. This is actually our product lah. So when CO2 is removed, so sama juga is actually when our reactant pula. When our product decrease. Okay, so when our product decrease macam mana? Okay, assume sekarang ni dia balance. Assume saja dia balance. Tapi dia kecil, dia yang di atas. So yang berat ni sini. So what will happen is that the equilibrium will shift to the right. Ataupun since the CO2, the product is removed, concentration of product. Yang ni buat ini macam pressure pula Concentration of product is removed ataupun kurang. Okay. So what will happen is that it will counter back by increasing the pressure, increasing the concentration of product. So macam mana nak increase the concentration of product? Dia mestilah nak change the reactant tu jadi product. So reactant change to product is actually reaction to shift to the right. Sama lah dengan seesaw kita tadi. So that's for question A. Next is question B. Some solid Na2CO3 were removed. So dalam kes ni, okay, Na2CO3 is actually on our product side. Tapi dia adalah solid. So dekat sini, okay, again, dia concentration lah. Maksudnya dia change in terms of concentration. But concentration is actually gas dengan equal sahaja. Okay, ni adalah solid. So solid ni does not include lah. So dia tak, it will not change kita punya Q ke K ke, it will not change anything. Okay, so what will happen? Sebab dia adalah solid, the same goes for liquid. So I'm just gonna write down here. Okay, why solid and liquid will not change the concentration and the equilibrium position? Sebab for the case of solid and liquid, actually the value is constant. Where the punya value of concentration tu sebenarnya is 1. So what will happen? Kalau kamu tukar pun sama sahaja. So when it does not change the concentration, hence it will not change the equilibrium position lah. So dekat sini apa yang kita akan jawab? So we're gonna write down here, it's actually it will have no changes lah. No changes. Okay, so ini adalah sebab kita tengok solid. Okay, C ni. Some solid NaHCO3 were removed. NaHCO3 ni is actually our reactant, tapi dia adalah solid. So sama juga. There no changes. Okay, again, concentration hanya kat sini misalnya concentration involving gas dengan equal sahaja. Kalau pressure, gas sahajalah. Okay. So contohnya kalau kita nak tengok dekat sini, in terms of pressure dia, sini, kat sini tak ada gas kan. So kita assume yang pressure dia ni, untuk yang pressure tu, dia jadi yang 0 mol. So pressure dia, kita kurang lah, 0 mol. Mestilah. Yang ini Na2CO3, H2O gas, CO2 gas. Kalau kat sini in terms of pressure ni, dia akan jadi 2 mol dekat sini. So pressure high. So kalau again, pressure involving gas sahaja. Okay. So that is for our question number 3. Okay. Question number 4 ni, I believe you could try yourself. The same goes for question 5 dengan 6. Question 7 pun sama juga. Okay. Tapi dekat sini what would be the effect? So sebab sini ada banyak bagi ruang kan. So kita jawablah macam kita tengok kat nota kita ni lah. The reaction will occur in the direction to increase pressure. Yang point ni sendiri. Sebab yang question yang nombor on page berapa ni, second last ni, dia nak predict the direction sahaja kan. How does the equilibrium position shift? Sebab itulah kita just explain equilibrium will shift to where? Right ataupun left ataupun no changes. Tapi kat sini dia minta what would be the effect. So nanti kat sini last dia tu bagi tahu lah juga will not only shift to the right or left. Sebenarnya concentration O2 ni increase ke apa? Concentration of O3 ni increase ke decrease? Okay, but no worries, nanti misalkan includekan dalam Google Form punya question. Okay, question 8 dengan 9 ni lain sikit. Sini kita tengok. Explain how the product could be increased. So when product could be increased, product ni is actually on our product side, is actually on the right side lah kan. So dalam case ni, what would happen is that kalau boleh kita nak semua reaction ni shift to the right. Okay, so how we're gonna shift to the right? So kita kena tengok in terms of 3 factors lah yang kita dah belajar. So yang inert gas tu, catalyst no change. Inert gas tu constant pressure, constant volume. Volume tu no change. Kalau constant pressure, macam pressure decrease lah kan. Okay. So kita punya in terms of kalau kita change concentration ke, temperature ke, pressure ni, we want it to be shift to the right. Okay, tapi sebelum apa-apa from this equation, Miss nak buat dulu. So dia adalah negatif. So dia adalah exothermic. So when it is exothermic, heat is released. So heat dia kat sini Heat dia di sini. Okay, lagi dekat sini kita tengok in terms of pressure. So pressure hanya gas sahaja. Okay, so that is actually question yang number 8 ni. Okay, so right now what we're going to do is actually change the concentration. The reaction ni will shift to the right. Temperature ni kalau kita nak ubah pun kita nak dia shift to the right. Pressure ni pun kita nak buat dia supaya shift to the right. Okay, so first one, concentration. So in terms of concentration, kita nak dia shift to the right lah. So bila kita nak dia shift to the right, maknanya kita nak form banyak lagi N2O4. So contohnya kita kacau yang NO2 ni lah. Contohnya, first one I'm gonna do is actually kalau kamu tak pasti boleh macam main try and error lah. So NO2 ni, so sekarang ni dia balance kan. So dia balance. Okay, so sekarang ni apa kamu nak buat? Nak increasekan NO2. So when you try to increase NO2, so what will happen? Dia akan jadi macam ni lah. Kan? Dia jadi macam ni. Cik. So bila tak balance, dia shift to the right. Betul tak? Nanti bila shift to the right, concentration of N2O4 increase lah. Okay, so maknanya first one kita akan increase the concentration of NO2. So that's the first one. Itu in terms of concentration. Okay, sebab kalau contohnya nak buat in terms of product pun boleh juga. Tapi sebenarnya kita nak memang shift to the right kan. Okay, next is temperature. So first kita buat when temperature increase, okay, the system will try to counter back by decreasing temperature. Tapi kalau kita decrease the temperature where there is no heat, actually on our right hand side pula. Left hand side pula tak nak lah. Kita kan nak right hand side. Okay, so kalau kita decrease the temperature, okay, the system tu will counter back by increase the temperature balik. Increase the temperature tu is actually on our right hand side. So boleh lah. So barulah kita boleh cakap the second one is actually we try to decrease temperature dia. So nanti dia try to achieve equilibrium by increasing the temperature by shifting to the right. Okay, last but not least is actually by changing the pressure. Okay, so first one. Okay, kalau kita increase the pressure, okay, yang ini dia memang macam kita cuba je. Jadi sebab increase, decrease kan. Try je lah. So when we try to increase the pressure, what will happen is that the system will counter back by decrease the pressure. So kalau decrease the pressure, kita tengok kat sini. Dia shift to the right. So inilah yang kita nak kan, yang shift to the right. So apa yang kita nak kacau is actually increase the pressure so that the system will counter back by decreasing the pressure. Hence it will shift to the right. So that is actually for the factors lah. Dalam ni dia terbalik sikit. Yang ini kamu boleh cubalah. Increase ke decrease. Cuba sendiri. Lepas tu tengoklah dia shift tak to where the question wants. Okay, so that is actually for question 8. Okay. So question 9 ni, I believe you could try yourself. So this is actually the last video for chapter 6.